Hello class. In the previous video we looked at frequency tables and histograms. Now we're going to look at descriptive statistics and the scatter plot. So right here I've already created a little table. This is going to be table 2 because table 1 of course is the frequency table of presidents' ages. Now we've got table 2, which is going to be descriptive statistics of president ages and heights. I've already put down mean, median, mode, range, and standard deviation. I've already got our variables here, age and height. So let's get started. So we're going to calculate the mean. As you know, the mean, the median, and the mode are all measures of central tendency. So they describe typical things about a data set. The mean, of course, is the arithmetic average. I'm sure you've calculated averages many times. And we're going to, of course, use the functions to do this. There's more than one way to calculate descriptive statistics, but the functions way is very easy to show you. So we're going to go over here to the function toolbar, just where we have been for the previous video. Type in the equal sign and the function. Now the function is not mean. It's actually average. So if you start typing in the word average, you'll see several things pop up, but we want this one, the second one that says average. Returns the average arithmetic mean. That's what we want. So we'll double click on it. And then of course it wants us to highlight the data so it can calculate the mean. So we're going to highlight all the ages. Just like usual, close a parentheses, hit return. So the mean is 54.8. So the average age of U.S. presidents is 54.8. We could just say 55. The median, of course, that's also a measurement of central tendency. It shows you the middle of the data set. I bet you it's going to be close to 54.8. What do you think? There's a function for that. Type in equal median. So it's called median. We're going to be doing the exact same thing. Put the parentheses around it. 54.5. So the median, as you know, is the exact center of the database. We have 38 presidents. And so if you look at your book, it explains how it finds the median. If it's an odd number, you just find the absolute middle value, and that's the median. If it's an even number, you find the two middle values and get the average of them. So as it turns out, the two middle values are Van Buren and Harding. So Van Buren was 54, Harding was 55, and so if you average 54 and 55, you get 54.5. So that's the median. The mode is the most commonly occurring value in the data set. I bet you it's going to be something around 54 or 55. Let's find out. So type in the equal sign. Start typing the word mode. Of course, you have a few different options. We're going to go with mode.sngl. So that's a single mode. Type in, of course, we're going to highlight our data. $54. Surprise, surprise. So if we look over here, 1, 2, 3, 4, there's 5 54. So 5 presidents were age 54. Of course, we had Harding, Johnson, and Harrison were 55. There were several 57-year-olds, but there's only one number that has the most, and that's 54. Range is our next. Of course, range is a measure of variability. So we're looking at how dispersed the data is. In statistics, people are very interested in talking about the variability in data sets. Range, you already know, is the largest number minus the smallest number. And so, of course, we remember that Reagan was our oldest president at age 69. Roosevelt, age 42. 69 minus 42 is 27. And then, of course, our standard deviation. Yes, there's a function for that too. So type in equals. Now it turns out it's a little bit abbreviated, just so you know. So ST, so when you get here you see two, stdev.p and stdev.s. So which one is it? Well, .p refers to a population and .s refers to a sample. So which is this, a population or a sample? It's a population because we have all 38 members of the population. All of the US presidents are in this data set. If we had taken a sample of, say, 10 of the 38, that would be a sample, and we would use the standard deviation.s. But we don't have that. We have all of them, so that's a population. So double click on that one, and then select all of the age numbers, close the parentheses, hit enter. 6.47. So that is the average variability from the mean. So the mean we know is 54.8 or 55, and so that means on average the ages vary around the mean around 6.47. So that's what that refers to. Standard deviation is the most popular measure of variability and an extremely important statistic or parameter in this case, since it's a population. Okay, you can see that I've jumped ahead and I've already filled out the descriptive statistics for height. I did it the exact same way. I showed you how to calculate all the descriptive statistics for age. So now we have a table that shows the descriptive statistics of presidents' ages and their heights. So next, we're going to do a scatter plot. Now, as you know, a scatter plot is what is used to show the relationship between two quantitative variables. Of course, our quantitative variables are age and height. Age and height. So in order to do this, of course, we're going to highlight both age and height. And because this is a chart, a scatter plot is a kind of chart. There are many examples in your book. We're going to go to Insert tab, and then we're going to go and look in all the different charts possible. And we see right here, there's one called Scatter. We just want the plain scatter chart. So we'll click here on the first one. And so here it is, and this looks sort of like an unholy mess. You're looking at that and you're like, I don't even know what's going on here. Part of the problem is that the horizontal axis is not appropriate. The horizontal axis is age. And so it starts with 0 and goes up to 80. Okay, the president's ages start with 42. So what is all this 0 to 40 stuff doesn't even need to be here. So we can edit that, thank goodness. Otherwise, you can't tell anything about this data. So we're going to click so that the x-axis numbers are highlighted. We're going to right-click. We're going to go to Format, Axis. Axis options. We have all these minimum. We want to look at the minimum and maximum. So right now we have it auto, which means it automatically chose 0. So we're going to click on Fixed, and I think we should change that to 40. 40.0. And of course our maximum was at 80. Now the oldest president was Ronald Reagan at 69, so we could make it 70. Major unit is 10. That's probably okay. Minor unit, that's probably okay. I think everything else is better, so let's go ahead and click OK. Okay, so now our axis is a little better. It looks like the vertical axis is actually reflective of what the ages, the heights are. I'm going to go ahead and get rid of this little legend. And I'm going to, now we're going to, this is our title. So we'll call it scatter plot of U.S. presidents' ages and heights. And that's quite big. So we can actually, if you highlight that, you can change the font size to something smaller. Let's do it that way. That's a little better. Now let's add some titles to our X and Y axes. So we're going to click on our scatter plot. Up here at the top we have chart tools that are available to us. Let's click on layout. Let's go to axis titles. We want primary. Let's do a horizontal axis title. So let's have the title below the axis. Of course, the x-axis is age. So we can just type in age. We could type in U.S. president's age if we wanted to, but we know up here by the title it is U.S. presidents, so we could just put age. And then we want a vertical y-axis title as well. So back to the x-axis title, primary vertical axis, and we want it to be, we'll make it a rotated title. So that means it's sideways. So that means I'm going to have to read this sideways. And so this is height. Height. Okay, so now we have a title of our scatter plot, and we have an X and Y axis titles. So we know what everything is. Under here is age, and up here is height. So we could then, knowing that, we can look at this and say, does there appear to be a relationship between age and height? Well, we know from reading the book that what you're trying to check for is if there's a linear relationship. That's what we're interested in. Is there a linear relationship? And you want things to be lines. Like a positive linear relationship would resemble, close sort of, a line going this way. A negative relationship would be a line going that way, sort of. Quite honestly, I'm not seeing any of that. To me, it looks just sort of like a circle or a blob. There does not appear to be a linear relationship between height and age. So I would say that there is probably no relationship between height and age. So now we have completed all of the things you need to do your homework. So you've got a frequency table, you've got a histogram, you've got a table that shows the descriptive stats, and you've got some scatter plots. And of course we discussed the scatter plot. The book goes over all of these things. Please feel free to reread the book if you need to. Ask me any questions, of course, if you're having trouble understanding something.